Solve. If a system's equations are dependent or if there is no solution, state this. 6x plus 2y minus 4z equals 15. Negative 3x minus 4y plus 2z equals negative 6. 4x minus 6y plus 3z equals 8. When I look at this system of equations, I notice that this is a plus 2 and a minus 4. And therefore, if I take this first equation and multiply by 2 on both sides, then I'll have a positive 4. I can add it to this equation to eliminate the y's. So let me draw a line so as not to confuse things. Let me take the result of multiplying by 2, 12x plus 4y minus 8z equals 30. Then I will write this equation as is, negative 3x minus 4y plus 2z equals negative 6. Add those equations together. 12x minus 3x is 9x. The y's sum to 0. Negative 8z plus 2z is negative 6z equals 30 minus 6 is 24. All right, now let's see what we can do. You want to use this first equation, and if I multiply by 3, then I can add it to the third equation and eliminate the y value. So I'm going to multiply that first equation. Instead of by 2, I'm going to multiply it by 3. All right, so let me write the result of that down below here. That would be 3 times 6x, 18x. 3 times 2y, 6y. 3 times negative 4z, negative 12z. 15 times 3, 45. Then I write down the third equation as is, 4x minus 6y plus 3z equals 8. And now I add these equations together. 18x plus 4x is 22x. The y's sum to 0. Negative 12z plus 3z is negative 9z. 45 and 8 is 53. All right, so now I have two equations with two unknowns, x and z, x and z. But I want to show you something, which is let's take this equation, rewrite it here, but divide both sides by 3. Because 9x divided by 3 is 3x, negative 6z divided by 3 is negative 2z, and 24 divided by 3 is 8. And that makes it a little bit easier now to use those two equations to solve for x and z. So let's eliminate the z. We'll do that by multiplying this first equation by negative 9. So we're going to multiply negative 9, negative 9. The second equation, we'll have to multiply both sides by 2. The result of multiplying the first equation by negative 9 is negative 27x plus 18z equals negative 72. The result of multiplying the second equation by 2 is 44x minus 18z equals 106. Notice that the z's have opposite coefficients, so they will be eliminated. Over here we have positive 17x is equal to negative 72 plus 106 is positive 34. Dividing both sides by 17, we get x equals 2. What we now do is substitute that value, x equals 2, into one of the equations that has both x and z. So I will choose this equation, substituting 2 for x. 3 times 2 is 6, minus 2z equals 8. Subtract 6 from each side. Negative 2z equals 2, and therefore z is equal to negative 1, which we get by dividing both sides by the negative 2. 2 divided by negative 2 is negative 1. Now we use the value z equals -1 along with the value x equals 2. We substitute that into one of the original equations. We have 6x plus 2y minus 4z equals 15. X is equal to 2. We don't know y. Then it's minus 4 times z, which is -1, equals 15. Let's simplify the left-hand side. And so 6 times 2 is 12 plus 2y minus 4 times -1 is positive 4. 12 and 4 is 16. So 16 plus 2y equals 15. Subtracting 16 from each side, we get 2y equals -1. Dividing both sides by 2, we get y equals -1/2. I've checked this answer, so I know it is correct. So what we have is the solution is the point x is positive 2, y is -1/2, z is -1.